Hi, everybody. It's Professor Mitchell. We are continuing with Chapter 3, and today we're looking at Section 3.5 on equations of lines. In this section, we'll use the slope-intercept form to graph a linear equation. We'll use the slope-intercept form to write an equation of a line. We'll use the point-slope form to find an equation of a line given its slope and a point on the line. We'll also use the point slope form to find an equation of a line given 2 points on the line. We'll find equations of vertical and horizontal lines. And finally, we'll use the point slope form to solve problems. And just like with the rest of this chapter, we're doing SLOC, constructing graphs of linear functions. All right, so graphing using slope-intercept form. First, recall that slope-intercept form is y equals mx plus b, where m is the slope and the y-intercept is 0, b. So, and in any problem, m and b will be specific numbers. And it's helpful to think of m as rise over run. So with that, I can explain to you now how to graph a line using slope-intercept form. Switching over to the tablet. Our first example is y equals 1/4 x minus 3. So first of all, notice that this is already in slope-intercept form. So the first thing we want to pull out is the y-intercept, which is 0, -3. So I'm going to plot that point. And now I'm going to use the slope, which is 1/4. Think of that as rise over run. And that basically gives you directions to the next point. So starting at 0, -3, I'm going to rise 1 and run 4, which will put me at this point. All right, I think I can do that one more time. Rise 1, run 4, puts me right here. All right, and now I will do my best to draw a straight line through those 3 points. There you go. All right, so that's how you graph using slope-intercept form. It's been my experience that this is a favorite method for a lot of students. A lot of students like to do it this way. And I can see it's pretty easy. It's actually very easy. All right. Next example, 3x plus y equals 2. So with this one, just notice that the equation is not written in slope-intercept form. So first we have to put it in slope-intercept form. And we'll do that by subtracting 3x on both sides, which is going to give us y equals -3x plus 2. So the y-intercept is 0, 2. And the slope is -3. And because that's an integer, I should think of it as -3 over 1. So starting at 0, 2, we're going to rise -3 and run 1. So of course, rise -3 means go down 3. 1, 2, 3. And run 1 means go 1 to the right. Doing that one more time. 1, 2, 3. Run 1. All right, so the graph of this line looks something like this. I think that might be my best one yet. All right, so that's the idea behind graphing using slope-intercept form. All right, so now we return to our list of methods for graphing linear equations. In previous sections, we've been adding to this list, but it's never been complete. But now it will be complete because using the slope and y-intercept is the last of the three methods we have learned for graphing linear equations. The first method was the point plotting method. Second method was using the intercepts. And now we're adding the slope-intercept method. Woohoo! So we have all three methods. All right, so the next objective is to write equations using slope-intercept form. So in this batch of problems, we will write an equation of the line with each given slope m and y-intercept 0b. These problems are very, very easy. I hardly ever say this, but on a scale from 1 to 10, these are all ones. So going over to the tablet. Again, they just want us to write the equation y equals mx plus b. Uh-oh. There we go. So if m is -2 and b is 3, then y equals mx plus b just becomes y equals -2x plus 3. And if m is 1/2 and b is -1/3, then the equation is y equals 1/2 x minus 1/3. Isn't that easy? All right, the only way I can think of to make it even slightly tricky is to make one of the numbers 0. But even that's not tricky. So again, y equals mx plus b. If m is 4 and b is 0, then this becomes y equals 4x plus 0, which we can just write as y equals 4x. And finally, m equals 0, b equals -6. I might start off writing y equals 0x minus 6. But then you can simplify that to y equals -6. Done. All right, let's see what's next. Okay, so now we'll talk about point slope form. So this is another one of those things that I'm only going to do it this way just this one time, just so you can see where this comes from. So here's an example I made up 100 years ago. What is an equation of the line with slope 2 passing through the point 3, 5? So first of all, the reason I can't easily use slope-intercept form for this is because I'm not given the y-intercept, right? The point 3, 5 is not a y-intercept. Y-intercept always has an x-coordinate of 0. All right, so I'm going to talk you through how you might do this the first time, but then after that, you never have to do it that way again. So I'm going to say that if xy is any other point on this line, then it must be true that 2 is equal to y minus 5 over x minus 3. Can you see where I got that? Well, that just comes from the slope formula. Remember the slope formula, m equals y2 minus y1 over x2 minus x1. That's where I got that. And now if I clear the fractions by multiplying both sides by x minus 3, I get y minus 5 equals 2 times x minus 3. So that is a perfectly legitimate equation of that line. It's not written in slope-intercept form. In fact, we call this form point-slope form. So this is another formula. The point-slope form of the equation of a line is given by the formula y minus y1 equals m times x minus x1. And let me be clear, in any given problem, x and y will be variables and they will stay in the equation. M and x1 and y1 will be specific numbers. So I have two different kinds of problems to show you involving point slope form. Oh, and of course, where m is the slope of the line and x1, y1 is a point on the line. So we either need, in order to write the equation of a line, we either need to be given the slope and a point on the line, like in these two examples, or we need to be given 2 points on the line. So let's go over to the tablet and I'll show you how these problems work. All right, so in the first example, m is -2, and the line passes through the point -11, -12. So we're going to use the point slope formula. Y minus y1 equals m times x minus x1. We'll replace m with -2, replace x1 with -11, and replace y1 with -12. Notice this formula has some built-in minus signs. All right, so now that I've got it all written out, let's clean that up a little bit. We'll write y minus -12 as y plus 12. Write x minus -11 as x plus 11. Now I'll distribute the -2, which gives me y plus 12 equals -2x minus 22. Now, one thing that I didn't think to point out on the presentation was that they want us to write our answer in standard form, which is ax plus by equals c. All right, so that means x and y on the same side of the equation and just a number on the other side. So there's more than one way to do that. I think what I'll do is add 2x to both sides, so we get the x and the y on the left side. That's going to give me 2x plus y plus 12 equals -22. And now I'll just subtract 12 on both sides. And that gives me my final answer, which is 2x plus y equals -34. All right. So I'm going to have you try the next one. You know the drill. Pause the video, do the problem, come back, compare notes. In this problem, m is 2/3, and we're passing through the point -8, 9. So please pause the video and try that one, and then we'll go over it. All right, so once again, using the point slope formula, y minus y1 equals m times x minus x1. M is 2/3. X1 is -8. Y1 is 9. So we have y minus 9 equals 2/3 times x minus -8. So we'll pretty that up, make it y minus 9 equals 2/3 x plus 8. All right, now one minor issue in this problem is that we have this fraction. One nice thing about standard form is that you can always write the answer without using fractions. So this step is technically optional, but it will make the answer look a lot nicer, and it will also make the math easier. We didn't have to do this in the last problem. I am going to multiply both sides of this equation by 3, because that will get rid of that fraction. This 3 will cancel this 3. And that will leave us with 3 times y minus 9 equals 2 times x plus 8. Now I'll distribute the 3 and distribute the 2. And that'll give me 3y minus 27 equals 2x plus 16, sorry. Okay, so now we have to get x and y on one side, get just a number on the other side. This is me being a little obsessive about making the answer look pretty. This time I'm going to put the x and the y on the right side, and that's only because if I can avoid it, I like to not have it start with a negative. Again, totally optional. You could put them on the left side. So that's going to give me negative 27 equals 2x minus 3y plus 16. And now I will subtract 16 on both sides. And I have just enough room to write my final answer. I am going to put 2x minus 3y on the left side. And then on the right side, I'll put the negative 43. So please note that if you got the answer negative 2x plus 3y equals 43, that is also correct. Okay, it represents the same line. In the next batch of examples, we are finding the equation of the line passing through two given points. This problem has one additional step at the very beginning. Notice that we're not given the slope. So the very first thing we have to do is find the slope, and we'll do that using the slope formula. Call this point x1, y1, call this point x2, y2. So m equals y2 minus y1 over x2 minus x1. Y2 is 8, y1 is 2, x2 is 8, x1 is 6. 8 minus 2 is 6, 8 minus 6 is 2, so the slope is 3. And now it becomes just like the type of problem we were doing before. So now we do have the slope. We're going to use the point slope formula to finish it off. Okay, so I am going to put 3 in for m. Please note that you can use either one of these points, either 6, 2 or 8, 8, to fill in for x1, y1. I'll go ahead and use 6, 2. One nice way you could check your answer is try it again with 8, 8 and just make sure you get the same equation. All right, distributing the 3, we get y minus 2 equals 3x minus 18. And again, I'm going to put the x and the y on the right side so that I can keep that 3x as a 3x and not have it become a negative 3x. So that's going to give me negative 2 equals 3x minus y minus 18. Adding 18 to both sides, we get our final answer, which is 3x minus y equals 16. All right, and the very last example in this batch, please try this one. Pause the video, try it, come back and compare notes. Finding the equation of the line passing through the points 0, 0, and negative 1/2 comma negative 1/2 comma 1/3. Okay, pause the video, try that. All right, so if we call this point x1, y1, call this point x2, y2, using our slope formula, y2 minus y1 over x2 minus x1. We get 1/3 minus 0 divided by negative 1/2 minus 0. 1/3 minus 0 is 1/3. Negative 1/2 minus 0 is negative 1/2. So how do you divide 1/3 by negative 1/2? Well, dividing by negative 1/2 is the same thing as multiplying by the reciprocal. So that's going to give me a slope of negative 2/3. All right. And at this point, the problem actually becomes quite easy because one of the points we're given is 0, 0. So once we put in 0, 0 for x1, y1, we're just left with y minus 0 equals negative 2/3 x minus 0, which is y equals negative 2/3 x. And I'm going to do the same thing I did before. I'm going to get rid of the fraction. I'll multiply both sides by 3. That gives me 3y equals negative 2x. Remember, we need x and y on the same side. So if I add 2x to both sides, I end up with 2x plus 3y. What do I get over here? 0. Once an equation, always an equation. I have to write equals 0 on that side. All right, back to the presentation. Okay, so the next thing is some more with horizontal and vertical lines. We've done a little bit with horizontal and vertical lines, I think, for the last, 3 or 4 sections now. So in this problem, we're going to find an equation of each line. The first one is a horizontal line through the point 1, 4. And then the second one's kind of fun. A line that is perpendicular to the line y equals 5, passing through the point 1, 2. So back to the tablet. All right, so what do you remember about horizontal lines? Hopefully you remember that a horizontal line, well, there's a couple things you could say here. You could say that the slope is 0, or you could say that the equation of the line has the form y equals a number. So now the question is, what number? Well, we're told that the line passes through the point 1, 4. 1 is the x, 4 is the y. So what all of the points on this line are going to have in common is that y is going to equal 4. And if you draw a picture, it might help you see why that's correct. Here's the point 1, 4. If you draw a horizontal line through that point, you can see that every other point on that line is going to have a y coordinate of 4. So horizontal and vertical line problems should take you all of about 30 seconds if you really know your stuff when it comes to horizontal and vertical lines. All right, so I really enjoy this problem. It's kind of like a puzzle. The line we're looking for is perpendicular to the line y equals 5, and it passes through the point 1, 2. So let's start talking about y equals 5. Y equals 5 is what kind of line? Well, just like in the last problem, it's horizontal. So a line that is perpendicular to that line will be so here's my horizontal line. My perpendicular line will be vertical. So this is just a fancy way of asking for an equation of a vertical line through the point 1, 2. Vertical line has the form x equals a number. What's the number going to be this time? Well, in this point, x is 1, y is 2. So what all of the points on this line are going to have in common is that the x coordinate is going to be 1. All right, I believe we have almost reached the end of this section. And by the way, after this, there's only one more section in chapter 3. Yes. All right, a little application problem involving linear equations. In 2011, there were 960,000 eating establishments in the United States. In 2006, there had been only 935,000 eating establishments. So the number of eating establishments increased from 2006 to 2011. So in the first part of this problem, we're going to write an equation describing the relationship between time and number of eating establishments using ordered pairs of the form X is the years past 2006, the number of years since 2006, and Y will be the number of eating establishments in thousands. And then once we have that, and I updated this problem because it was a little out of date, we're going to use this equation to predict the number of eating establishments in 2023. Before I updated it, it said 2018. So that wouldn't have been much of a prediction. It was when I first started using this problem. All right. Okay, so over to the tablet. Now remember, they wanted us to use ordered pairs of the form years past 2006, comma, number of eating establishments. Sometimes I think about why didn't they just say restaurants? Well, there's other kinds of eating establishments, right? Taco trucks and that kind of thing. In thousands. Writing the numbers in thousands will give us more manageable numbers. All right, so let's start with 2011. So my first question about 2011 is how many years after 2006 is that? Well, it's 5, right? And how many thousand eating establishments were there in 2011? There were 960,000. Okay, for the other pair, how many years past 2006 is 2006? It's 0, right? And the number of eating establishments that year was 935,000. So we have our 2 ordered pairs. Let's call this one x1, y1. We'll call this one x2, y2. First thing we have to do is find the slope. y2 minus y1 over x2 minus x1. y2 is 960. y1 is 935. x2 is 5. x1 is 0. 960 minus 935 is 25. 5 minus 0 is 5. 25 divided by 5 is 5. So the slope of this line is 5. Remember, the second part of this type of problem was to use the point slope formula. Y minus y1 equals m times x minus x1. There's another way you could do this problem, by the way, this part of it. Okay, so I'm going to use 5 for the slope. And then for x1, y1, I'm going to use the point 0, 935. So 0 will go here. 935 will go here. Y minus 935 equals 5 times x minus 0. Gives me y minus 935 equals 5x. I don't think they told me how to write this or what form to write this equation in. So when they don't say what form, I usually go to slope-intercept form. All right, so this equation would be y equals 5x plus 935. So the idea is you give me a year, and I will use this equation to predict the number of eating establishments in that year. For example, letter B, how many eating establishments and keep in mind this is just a prediction. Okay. So the first thing we have to figure out is how many years past 2006 is 2023. Well, that's a subtraction problem, right? 2023 minus 2006 is 17. So that's going to be x. Using the equation y equals 5x plus 935. And I have never done this exact problem before because I just updated the year to 2023. We're all going to see this answer for the first time together. All right, this equation, this model predicts that in 2023, the number of eating establishments will be 1,020,000. Or, I think that sounds kind of funny, 1,020,000. That means this many, 1,020,000. All right, and that is going to do it for section 3.5. We will see you next time.